Hi everybody, welcome to the video about using the definition of a derivative and power rule together in order to solve for some derivatives of functions. So here we have f of x is equal to 2x squared plus 1, and let's start with the power rule that we derived last time. We know the power rule is when we have a function f of x is equal to a times x to the n, where a is just a constant, f prime of x, a times n times x to the n minus 1. So it's the same thing as multiplying the exponent out in front and subtracting 1 from the exponent. So if we do that for f of x of our function, we have f of x is equal to 2x squared plus 1. If we multiply it by the exponent of each of the x values, and minus 1 is the same thing as saying x to the 0 power, we can say that f of x, or f prime of x, is equal to 2 times 2 times x to the 2 minus 1, which is just x to the first power, minus 1 times 0, and so anything times 0 is just 0. So we can see that f prime of x is equal to 4x. Very fast and very easy, so that's good. But now, let's use the limit definition of a derivative in order to solve for it, and it's much longer, which is why we like the power rule. Where we have the limit of h approaching 0 of our function of f of x plus h minus f of x divided by h is just our derivative. So let's solve for that. We have the limit of h going 0 and x plus h into wherever we have x terms. So we're going to have 2 to the x plus h squared plus 1 minus the f of x function 2x squared minus or plus 1 divided by h. And so we're going to have this quantity that we actually need to expand, and also we can subtract out the 1 terms. So we're going to have our limit of h approaching 0, and I'm going to cancel out our 1's right away, and I'm going to expand out our x plus h, where we're going to get x squared plus 2h of x plus h squared minus 2x squared in the numerator divided by h in the denominator. And we'll find out that the limit of h approaching 0 of our function now is going to be 2x squared plus 4hx plus 2h squared minus 2x squared divided by h. Our 2x squareds will cancel out because there's a positive and a negative, which makes it very easy. So I'm going to continue this over here. And all we're going to have is the limit of h approaching 0 of 4hx plus 2h squared divided by h. Our h's will cancel out on the top and the bottom, which just essentially makes this 4x plus 2h. And any terms that we have h's of the power of 1 or higher, like we talked about last video, because we can just plug in 0 for those terms, as long as there's no dividing by 0 in a fraction. And so we can evaluate this where we just end up getting 4x, which is the same thing as saying f prime of x. So between using the limit definition of a derivative and the power rule, this is why in most math classes, after you've solved a couple problems for the limit definition of a derivative, we move towards the power rule, which makes it a lot easier. Please show your support for this channel by liking and subscribing, as all I want to do is help support students on their learning journey. But let's go through some more practice. Here we're going to have f of x is equal to 10x cubed plus x to the power of minus 2. So we're going to find f prime of x just using power rule in this case. F of x, I'm just going to rewrite it. We have 10 x to the power of 3 plus x to the power of minus 2, which is also saying 1 over x squared, but here it makes it easy by using the power rule. What we can do by using the power rule is we multiply by our exponents of the individual terms, and we subtract 1 from the power. So f prime of x And we're going to do this step by step. We're going to have 10, which is originally there, multiplied by 3 times x to now 3 minus 1. So this is where we get our x squared from this point. Now, we're going to have plus our specific term here, and we have our exponent to be minus 2. So we're going to multiply that out in front, and we're going to subtract 1 from our exponent now, where minus 2 minus 1 is the same thing as saying minus 3. And so now when we evaluate it, we'll get f prime of x is equal to 30 x squared minus 2x to the minus 3. Very simple, very easy, especially by using the power rule definitions for polynomials, where we just have the form ax to the power of n. Let's go through one more quick practice. We're going to use the power rule by solving for this specific function, but now we should get it into a form of a polynomial to make this easier on ourselves. So now we have x plus 2 squared divided by 3x. We want to get it into the forms of f of x is equal to a times x to the n. And we just want to have our terms individually like this, separated by addition or subtraction signs. So what we can do is we can expand x plus 2 squared, and then hopefully we can divide all the terms by 3x. So this is the same thing as saying x squared plus 2x plus 2x plus 4 squared, or sorry, 2 squared, which is 4, divided by 3x. We can combine our 2x terms, or any terms that have x to the first power, and we'll end up getting x squared plus 4x plus 4 divided by 3x. And now since we want to get into the a times x to the power of n, in this fraction, since we have only one piece or one term in our denominator, this is the same thing as saying x squared divided by 3x plus 4x divided by 3x plus 4 divided by 3x. And so when we find this, any terms on the top and the bottom we can cancel out. And so we have 1 over 3 multiplied by x plus 4 divided by 3 with no x terms. And now we also have plus 4 divided by 3. But now we have x in the denominator, which is the same thing as saying x to the minus 1 power. Now we haven't taken the derivative yet. We just got it into a form where we can use the power rule and make it a lot easier on ourselves. So now using the power rule, f prime of x is the same thing as taking the exponents and multiplying it by the coefficients out in front and subtracting 1 from them. So here we're going to have 1/3 multiplied by our power of 1 multiplied by x now to the 0 power. And essentially the same thing here. We have something with x to the 0 power or a constant. So this will just end up being 0, the 4 divided by 3. But now since we have a 4 divided by 3 multiplied by x to the minus 1, let's multiply it by its exponent, which is now minus 1, and subtract 1 from the power to get minus 2. And so when we fully simplify this specific function, we get f prime of x is equal to 1/3 minus 4/3 times x to the power of negative 2. And if you just want to make this very nice for your professor, you're going to get 1/3 minus 4/3 x squared on the bottom. Please comment below something you have learned through this video, and please comment also any questions you may have about any of these topics.